Everyone online, also in the room. So Changyan, you can do the admitting. So again, good morning, everyone, and good morning to everyone who joined us remotely. I hope you can hear me. If you have issues hearing, please put that in the comment box. And I really want to thank everyone who is joining us remotely and again, also in person. My name is Venkatesh Merwade. So we are here for our technically third workshop, but our first two workshops were virtual. So this is our first in-person workshop. And I met my OPIs in person for the first time. So we have been meeting online for the last 3 years. So when this project was funded, it was called RIMORPHIS, and then we realized that there is a company called RIMORPHIS. So we got in touch with them and figured out the name issue. So we renamed our system as RIMORPHIS, River Morphology Information System. So why did we start working on this project? So I think everyone in this room knows that we have issues with river morphology data. Some of these issues are listed here. So they are not easily available in public. So when I was working on river bathymetry, I did have access on some river bathymetry single beam data sets from Texas Water Development Board. And that's all I could have for my thesis. I couldn't find anything else in public domain or any other resources. So we do, and that is still a problem. I think the data availability is there, but it's available in research groups and organizations. But if you go and try to find river bathymetry similar to trying to find stream flow or rainfall, we cannot find river bathymetry data. So there is still an issue of access. The other issue that we have is these data sets are not cheap to collect. They take a lot of resources, both in terms of financial and human resources. So when we collect data, these are collected for specific projects for a very short reach. So they are not available for a large areas as Mike mentioned. When you're working on a CONUS scale, you need data at the CONUS scale, and we still don't have that. And again, these data sets are, we have single beam, we have multi-beam, we have cross sections. Some of them are old data sets, they are not even geo-referenced. So there are no tools available to pre-process and post-process data sets and give us a product that is really useful for everyone. So there are issues about access, there are issues about their availability over large areas and lack of tools. So what we wanted to do is we wanted to propose a solution. So we wanted to propose a user-friendly, scalable data and information system. So that is what we are calling it as. I'll stay closer here so people can hear me. So we want this platform, and you will see a brief demo today for discovery of data, getting data, and also do some sort of analysis depending on how you want that data to be. And finally, also integrate. So many times you have the river channel, but it's not integrated with the surrounding topography. So again, if you want to use these data sets for large areas, you want the topography, let's say the national elevation data set, plus the river bathymetry. So we wanted to have tools that can do the integration. And again, when people start using this, there is going to be new research, so new knowledge will generate. So that is something we want to accomplish from this. We start this for river bathymetry, but eventually the goal is to have other data sets related to river morphology. So sediment, I think that is one of the data sets that we keep discussing. Hydrodynamic data collected from ADCP and so on. So we want this system to be more comprehensive and include all these other data sets that we use for river research. And finally, we want our system to have visualization and collaboration tools. You will see some visualization today, but with collaboration right now, the way we have is some integration with other resources from where we can access data. We are also working on integration and with HydroShare, where we can have some sort of collaborative tool. So we just met, so we all know now. So the people that are not in this room is Cyan. So he was a student and a postdoc working with me, and I think many of you mentioned his name. I think he has been communicating with you, and to me, my students and my postdocs are my chat GPT. So I don't do anything. I just tell them, can we do this? And by magic, it happens. So Cyan, Changyan, and Rensi was a master student. So she created one tool. And I think it's the same Yusuf. So the top row is the one they do all the magic, and the bottom row we manage the project. So we meet bi-weekly, we talk about things, and we keep calling each other boss, but I think today's boss is Toby. So we didn't really mention that. So I really want to thank Toby for organizing this and taking care of all the logistics. So this was our vision for the proposal, and for some reason the texts are not showing up for this. Let's see, maybe I can stop. We'll avoid that correction. So for each box, there is a text that is not showing up, but that's okay. So in the next slide, we should see that. So the idea is to have a community self-sustained platform that can provide access to data, that can have tools, that can have visualization capabilities, and which can also enable multidisciplinary research for river environments. You don't see the names here. So the names that we have for these boxes, so RIMORPHIS, and we want to have this for the community. We want to have a good cyber infrastructure to support the platform. We want to enable research. We want to make sure that all these data sets can be accessed, and then we want to have tools. So what I would like to do in the next few slides is just talk about some of the work we have been doing for each of these circles. So as I said, we have been working with community for last 3 years, and we did that through workshops, and then we also had individual meetings, and I think many of you were part of those some meetings. So first 2 workshops were virtual. First workshop was in 2021, so we had really good attendance. The idea of this workshop was to basically learn what the organizations and community has to offer in terms of data, in terms of tools, and how we can incorporate those in our design and the platform that we were developing at that time. And we also wanted to identify our initial partners with whom we can work to enable the data access, and also see if we can use some of those tools. So as a part of that workshop, I think, so these are the names that you see at the bottom. So we identified those, and we have been working with them for the last 3 years. Then last year was our second workshop. So this was also virtual. Since it is virtual, we get a lot of international participants, even on the Zoom call today. I think out of those 17, 7 or 8 are international. Again, many federal agencies participated in this workshop: universities, NSF, GPL, quasi-industry. The idea of this workshop was to give a demo of the prototype and get feedback. And then in December last year at the AGU, we also had a town hall. Again, the idea was to showcase what we have, get feedback, and keep developing our system. And then at that time, we released the beta version of RIMORPHIS platform, which you will see today. and you will also have access to that beta version. So you can also play around with it during the workshop or after you leave, and then we will be happy to get any feedback from you guys. So this is our third workshop. These are the three objectives that we have for this workshop. So again, discuss what we have and the ongoing developments that are going on in terms of data, and mainly in terms of tool development. So some of the things that we have been working on, I will show briefly during my slide presentations. Then in the afternoon, we have a session on just discussing use cases for our tools. So we will have more time in the afternoon to go into detail about those. As I said, we have been working with many of you for the last 2 years. So we want to keep continuing that, but then we also want to think about building new partnerships as we think about the future of this project and the platform as a whole. So there is a need to keep building partnership if you want to sustain it at the community level for long term. So one of the partners we have is also Quasi, who could not be here. Hopefully, Jordan Reed, who is the new director, he is on the Zoom. Maybe if not, we will meet with them in one of our meetings. And as I said, there is a session this afternoon also to talk about the future plans and the path forward for sustaining RIMORPHIS. In terms of cyber infrastructure, after my presentation, Yusuf is going to dig detail into the cyber infrastructure part. So here I will just give you a brief overview of the thinking that went behind this. So what you see on this slide are points. So many times river data are available as points for bathymetry, or even on sediments or water quality. Many of these are available as points. Then we want to connect those points to cross-section, and the cross-sections are then connected to a reach, and a reach becomes a part of a stream network, and then the stream network is part of a watershed or a catchment. So everything that we are going to have in RIMORPHIS is going to be connected to an NHT reach. And then that's how we are going to geo-reference and tag everything that we are going to have in our system. So the idea here is again to have this connectivity so we can connect our tools and data with what everybody else is doing. So for example, the National Water Model, so they also give out predictions for all NHD reaches. So since we have the common link as NHD reach, and I think that is true with many other agencies. So that's how we want to make sure that what we do can be easily connected and used by many other researchers and organizations that we are working with. This is again a brief overview of how the architecture looks like. So we have the front end layer where we can have access to tools and data resources. Then behind that, we have the database and web service layer that will enable that access between the front end and our resources. As of now, we are not storing any data that you will access through RIMORPHIS. So everything is on the fly, if I'm correct. The only data set that we have is the skeleton, which is the NHD networks. So when you click on a reach and try to access data, that's when the data is fetched and displayed into the system. And that is what the visualization and mapping layer is. So visualization and mapping layer will enable visualizing in space and time of the data that we will serve. And then finally, we have the integrated modeling layer, which takes care of the tools and modeling components that we are going to have in the system. So again, as I said, Yusuf will talk about this in more detail during his presentation. This is just the image of the architecture I discussed in the last two slides. So we have the NHD hub catchment, we have the stream network, and you see the reach and junction there. And that's the the geodatabase view of that connectivity. And in addition to the database and the visualization, we are also developing APIs. So anybody can use RIMORPHIS tools and access the data that RIMORPHIS is accessing by using this API. So again, Yusuf will talk about this during his presentation. So the idea here is that we are developing the platform, but anybody could also use it remotely by using these APIs. I will now briefly talk about tools. So we are dividing our tool sets into 3 broad categories. So the first one is bathymetry tools. That is where my expertise is. We have satellite imagery tools. That is what Toby and his group is working on. And then we have sonar data tools. That is what Marian will discuss in his presentation this afternoon. So I'll quickly go over these tools, and as I said, we will spend more time going into details of these tools in the afternoon. So in terms of tools, so for our tools to work, we need access to data sets. So this is a conceptual view of how the data access works. So I'm showing you here an example of the USGS science base, and I think that's we have data, bathymetry data in science base, but you have to look for it when you find the data set. This is how it looks. It's an Excel file. So you cannot really use this unless you convert these numbers into points and lines. So the idea here is that our RIMORPHIS map interface will enable that access. So if you pick a reach, it can find out whether there is a data set exists for that particular reach. And then it will fetch that data and it will convert that data into a form that one can use. So you can see the cross section being generated from using those points. On this slide, you see an example of how this might work with the 3DEF data set, but we have actually implemented this for the eHydro dataset. So eHydro has lots of millions of points, so we are able to do this. And in the demo that Yusuf is going to show, you will see that. Once you have those points, how can we use them? So what you see here is an example of the tool that Changyan developed. So regardless of how your point data set looks like, we have tools that can create you cross sections from those points. If you have multi-beam, if you have single beam, if the data set is organized nicely in cross sections like you see here, if it is organized in zigzag pattern, regardless of the pattern, if you say give me cross section, it will give you cross section. And there is an algorithm behind that is making sure that the cross sections that you get are optimally placed. So it tries to extract as much information as it can from those points and give you cross-section at useful locations. So again, we will go into more details of those in the afternoon. So the idea of these tools is that we have data at multiple locations. So what you see here is map of Indiana. And by looking at this map, you may think that, oh, Indiana is covered with cross-section. It's great, but it is not. There are lots of gaps. So how can we fill those gaps? So what you see here are HEC-RAS cross-section, and you can see the blue line where the data is missing. So the question then is, how can we fill those gaps? So we have tools that can work with the cross-sections and point data set, and then convert synthetic bathymetry at those locations where we don't have data. So one of the tools is the Spring tool. So this is the tool that Cyan developed, which is working on top of the RCMM tool that I developed for my PhD. And I'm not sure what happened with the text here. So the idea again here is we have data at locations, and where we don't have data, we create synthetic bathymetry. So here you see a nice parabolic shape. Here you see a trapezoidal channel, and here you see a natural channel. So depending on what kind of data we have, we can create these bathymetry sections and incorporate that into a digital elevation model. As I said, these tools are trained on some data sets, so you can see how the data fits to our synthetic cross-section, and it's pretty good. Changyan is working on a deep learning model. So wherever we have data, we are using those data sets to train a deep learning model and create cross-section. And again, you can see the results are very promising. So the true profile is the blue line, and the orange line that you see here is created by a deep learning model. You can see it is capturing the shape. There is little bit of noise which we can filter and have a nice looking cross section. So we have those tools, and these are currently being implemented into RIMORPHIS. And finally, as I mentioned, once we have that river bathymetry, we want to integrate that into a DEM. So we are also working on a tool that will create an integrated DEM for you, like you see on this slide. So once you do all this over a large scale, you end up with a digital elevation model that has nice topography and also realistic river bathymetry that we can use for flood modeling or any kind of model that you're working on. So again, this is just once we have that continuous bathymetry, we can create a flood model. And this is an animation. For some reason, it's working really slow. So that's. We are also working on tools to track how the river bed or morphology is changing with time. So Cyan and Amanda are working on these tools, and we will hear more about this in the afternoon. Again, the idea here is that we are going to be having access to bathymetry resources. So there are some agencies that are collecting bathymetry data for many decades. So if we have access to those, then we want to have tools that can work on top of that and see how the riverbed is changing, or also how it is migrating. So we have a tool that works with Landsat data and captures river migration over time. So Rensi Pipalia, she just finished her master's thesis on this. So we have the tool which we will be incorporated in future in RIMORPHIS. So this is just a result from that. So this is for Wabash River. So you can see the river migration is not much until the 500-kilometer section, and after that it increases significantly, and this has to do with a confluence with another major river. But the trend is opposite for Mississippi, and this has to do with all the levees and other structures that are built, so it is not migrating that much. So again, you can do these kind of things when you have tools working with data over large scales. Satellite imagery processing tools. So this is the tool that Toby is working on. So the idea again here is, if you want to see an inundation corresponding to a particular flow or a discharge, we should be able to do that. So you look at the hydrograph, you pick a time depending on when it exceeded a certain threshold, and for that time, the tool goes on and finds satellite images and gives you inundation for that particular event or for that particular time duration we specify. And again, we will have time to talk about this more in the afternoon. Sonar tools. So Marian, as I said, he works with ADCP data. So we have been fortunate or lucky enough until now to get data for all the other things. So this is one where we are still working on to get access to a major database where we have ADCP data, so we can implement some of these tools. So the tools that you see here, visualization, they have been developed by some of Marian's collaborators. So we want to incorporate them into RIMORPHIS, but to do that, we need data. So this is something that we have been working on to have access to a database that will enable us to implement these tools. So ADCP data is very detailed and very nice. So if we can get access to that, we have very nice tools for visualization and processing. Yeah, so these are just slides explaining that. And then finally, as I said, we are also working with integrating our data and tools with HydroShare. So right now, a simple integration that is under development or almost close to finish is with HydroShare. The idea is that if we create a result in RIMORPHIS. So as I mentioned, RIMORPHIS is not storing any data at this point. So if you access eHydro, create cross-section, you either have to download them or store it somewhere. So we are working to make sure that a user can push those data sets and store in HydroShare. And same with accessing data. If HydroShare has some bathymetry data set, we should be able to access those, run our tools, and store results in HydroShare. So this is something that we want to finish this as a part of this project, so we can work on top of that for the next phase. So in summary, we have developed a community platform and a resource, and you will get a demo of that once Yusuf comes back. And we want to make sure that people can access, visualize, and process river bathymetry data collected by government agencies, but also hopefully collected by individual researchers. We are building partnerships, and we want to continue building this partnership so we can keep developing and hopefully sustain this platform over a long period. One of the ways to do that is integrate with already existing community resources. So one of those resources is HydroShare. And as I said, we have a beta platform, and you will see a link here for that beta platform. So this is the link to our project website. Right now, this website does not have link to the beta platform, but if you just add /platform, you will get access to the beta site. And if you have any questions, you can email us. I don't see Yusuf here, so Yusuf is going to continue and give you a demonstration and also discuss the cyber infrastructure part in detail until Yusuf shows up. If there are any questions that you have or the people on Zoom have, I'll be happy to answer. So with that, I'll briefly stop sharing. As I said, those of you who are on Zoom, we will continue with the cyber infrastructure presentation and demonstration. So with that, I will stop briefly here to answer any question. And I see Yusuf walking there. Very cool. So that's a very good question, Dave. I think Yusuf will cover that in his presentation. So Yusuf, if you are able to see that question, what are the formats and data standards?
So how about I give the presentation and after
yes,
we can maybe that will answer the question.
Yeah, so Dave, Yusuf is going to give his presentation and demo. Hopefully that will answer your question. If not, he will answer that question after his presentation. So if you want, here. I'll just.
Actually, you can maybe keep that. I'll just share my screen.
Yeah, that's right. Yeah.
We don't need to remove.
You don't need. Okay.
Yeah. Thank you. There we go.
Mute myself.
All right, so I'm assuming everyone. This one.
Yes.
Test 1, 2, 3. So no echo. Can someone on Zoom confirm that they could hear us?
Yeah, we can hear you.
Yeah.
Okay, fantastic. All right, well, hello everyone. I'm going to give a brief presentation on the architecture and the tool and implementation, and then I'm going to move forward with the demo. You can stop me anytime. Please feel free to stop me anytime to ask me questions. Yeah. Okay, all right. So briefly, the agenda, I'm going to start with the referencing system that Venkatesh already talked about, and then we're going to move on to the data resources we utilize, then the RIMORPHIS API, both the interface as well as the RESTful API that you could use in your own system. Then we're going to move forward with the data exploration and talk about visual browsing and how we present data. And then we're going to move forward with the 3D visualization and those kind of interactions with WebGL and DeckGL. And finally, analytics and sharing, which we're going to talk about the tools that we integrate in the system as well as sharing through HydroShare. You already know this, so I'm going to move past the cyber infrastructure. So briefly, starting from the user-facing side, we are utilizing a React-based content, completely modular. We equipped it with deck.gl and we put some optimizations in them so that the user is not bothered with all the calculations and computations that's going on behind. On the back end, we have a Node.js server, which also has its own little Python ecosystem so that we could run the tools for cross-section processing and raster generation as well. For database, we're utilizing PostgreSQL, equipped with PostGIS, as we are all familiar with it. And finally, we are using Postgres, which is a service, I'm going to say a library that builds a web server on top of the PostgreSQL server. And finally, we are using Nginx. I'm going to go into detail on that one. Regarding the referencing system, as Venkatesh mentioned, we are using NHD plus high resolution as our skeleton, as our umbrella system, where we connect the cross-section surveys and other relevant data so that we could work in this geospatial context. We start with HUC2 and go beyond HUC4 and HUC8, and then the NHD catchments and the flow lines and judgments. As you're all familiar with this, NHD plus catchments are basically is a partitioning of HUC12 areas, and yeah, I can maybe ask him that too. Regarding one thing that I want to mention before I move forward with the referencing system is the basically the sheer size of data. Just the referencing system alone brings a lot of not just the size of the data, but rather the number of files that we have to deal with in terms of JSON, because that's another difficulty when you're potentially, hopefully, serving thousands of people, thinking about the future. So currently, we are using 0701 in the demo, just to make sure that we focus on the tools and we'll talk about the expansion later on. Coming to the API side, in our database, we follow a semantic structure of starting from HUC, then going to NHD catchments, and then following flow lines. And for each flow line, we have associated cross-section surveys, which may be coming from the users, which may be coming from eHydro or any other resources. And to those cross-section surveys, we're going to annotate segmentation and routing tables. The major resource that we are using in the system right now is eHydro, which has substantial coverage in the entire United States. So currently, our system uses their API to fetch all the relevant data on demand, as Venkatesh said, on the fly. Okay, regarding the API, we have two manners of interacting with data. One is a visual interface, quite simple, so that users can explore and maybe try to plot things without without opening their Python notebooks. In this interface, you can check out other tables, you can disable, enable some parameters, you can filter, just like you would filter SQL, like the relational database. And if you want to use the API in your own ecosystems and cyber infrastructures, then you could just use our RESTful API. Here's an example. Since we are using Postgres, you can pretty much write SQL queries on a URL. We're coming to the demo, starting from data exploration. One of the considerations we have made was how to let users find the data that they're looking for. So we decided on visual exploration, where we don't want the user, or we're not going to rely on user to know which specific catchment they're interested in. Rather, we just let them open the map, zoom in. When we're at the upper zoom levels, we start with a larger HUC, and then as they zoom in, we change the context to smaller HUC sizes, and then initially catchments and flow lines, and finally we show available eHydro cross-section surveys in clusters. When they click on an eHydro survey, we first start with the KMZ that's coming to us from eHydro directly, and we put the relevant metadata as well. So this is before any processing. This is just the raw data that's coming to us. Another type of visualization, I'm going to go into detail on these later, but in addition for them to just observe the data in a finer level, we also provide this kind of 3D visualization so that they can intuitively understand, okay, how the riverbed is shaped. In fact, on this slide, we didn't put this on the slide, but we have a brand new visualization that shows you a different color schema so that it's a bit more intuitive than this. So basically, deeper levels are purple and the other levels are maybe yellow. Coming to the analytics. The first tool that we integrated is the cross-section processing tool. The folks at Purdue, Changyan and Sayan and Venkatesh developed. This tool is working in Python. And from the front-end side, it was our objective to make things as simple as possible. So that, again, the user doesn't have to know all the details or doesn't have to be bothered with doing all these configurations, so that they could start from somewhere. And then if they want, they could customize more. They could provide these different parameters to change the behavior of the cross-section processing tool and so on. And we have multiple formats to download the data for JSON and shapefile, and we are open to integrate more formats if there is any interest on that one. For eHydro, we are converting points to mesh, but we can also do point to cross-section or cross-section to mesh and other types of conversions as well. All right, as I mentioned, we have two modes of using the cross-section processing tool. The first one is what we call fully automatic, when the data is coming from eHydro or maybe potentially other places in the future. And for this scenario, they could just process the cross-section by defining the parameters for the tool. And the other scenario is when you have your own data that you want to maybe visualize on the system. Maybe you have something historical that you want to compare with current surveys. For example, for this particular scenario, it's a survey from Brazos River, I believe, from a couple of years ago, maybe more than 10 years ago, that you can just upload to our system as shapefile. Again, define the parameters and then observe how it looks. For example, for this scenario, it's interesting because this survey is actually, in fact, it may be better if I would enable the satellite image, because you could see, or you could potentially see how the riverbed changed over time. Another feature is the raster generation tool, which in addition to the cross-section processing tool, we put that as although it's a completely separate tool, again, to make things intuitive for the user, we just put it as a small checkbox here, and if the user would like to see that or observe that or maybe download that, they can just check this box. And in addition to all the other things, we provide the raster as well. So the raster is actually GeoTIFF, but since it's so large, We converted the JPEG at a reasonable resolution to show it on the web platform, but we have GeoTIFF for further geoprocessing if they want to download it and so on. All right, so coming to the HydroShare integration. We utilize HydroShare as a way for users to log into our platform through their third-party authentication, OAuth authentication. So the interface follows a workflow. As you log in through HydroShare, you then log in on HydroShare website, give us the authorization to read and write, and then you have your basic information, and we provide some settings that they can set as well. For example, maybe they don't want to see any detachments because it's slowing things down maybe for them in their own computer, or they could disable 3D view if, again, it's computationally demanding. Coming to sharing the data, let's say you utilize RIMORPHIS system, RIMORPHIS, to upload your own data, or maybe retrieving the data from eHydro, and then maybe you customize the parameters, and you want to share that with your colleagues. So to do that easily, we put a button there for you to upload this results of the cross-section processing in 3 different formats, so that you could just have a chat about it, or maybe try other things, and have it in a persistent file system as well. So we're relying on HydroShare, and although it's not quite visible here, we have the shape files of the output. We have the JSON in the original coordinate system, and we also have the JSON in 4326, so that they can use it on a web platform in Google Maps and such. Another option is that you could explore all the other resources that are compatible with RIMORPHIS that are uploaded to HydroShare, right? So again, these are retrieved on the fly from HydroShare, and these images are generated based on the scope that we received there. And these, by the way, this page is still under development. All of these messages are automatically generated by our system, which is why it looks kind of robotic a little, but that's a work in progress. All right, so that's about it. Maybe I could do one brief demo. Real quick. All right, so this is the system. We have the API here, the screenshots I showed you. If you want to visit the visual interface, you can go here. We have the resources that are dynamically retrieved, and you can visit them. But I'm gonna maybe show one example of processing a cross section. Retrieve from eHydro, and then we have the metadata. If you want to just check out the raw file, it's here as well. I'm not going to change anything for now. I'm just going to maybe download this JSON, let's say. Depending on your configuration and the size of the data, it can take maybe 10 seconds, maybe 20 seconds. So this is happening in Python. Okay, so it happened in a couple of seconds. That's great. And we are showing all 3 layers at the same time. We don't have raster because I didn't check that box. I'm going to disable the 2D where we have the processed cross-section points, as you can see on the right panel, if you want to just check out the things at the final level. I'm going to disable that. Just turn around and check it out and so on. We also download it as a JSON. Sorry. So you can potentially import it to QGIS and do further things. We can also upload this to HydroShare. Uploading to HydroShare for this scenario may take a bit more because to be on the safer side, we are uploading all 3 different types of formats of the same file to suit different use cases. We can customize it in the future, again, depending on the needs. While we are, by the way, everything is happening asynchronously. So while you're maybe uploading that, you can still interact with the system. You can maybe check out other cross sections as well, and so on. So while we're doing that, the HydroShare upload is completed. Again, these are all automatically generated. We're going to fine tune these annotations, maybe put some more information regarding the parameters that were used in processing. And here are the resulting files. All right. So that's about it. Thank you.
Thank you, Yusuf. So I think in the last part of this presentation, he mentioned HydroShare a lot. How many of you are not aware of HydroShare? Yeah, so few of you are not. So HydroShare is a community resource. It is a NSF funded project. It's been under development for last more than 10 years, I think. And currently it's being hosted by Quasi. I hope you know Quasi or maybe not. So it's a quasi resource in a sense, which means it's going to be sustained in the long term. So that's why we want to have that integration, and the Quasi community then also have access to RIMORPHIS and vice versa. So HydroShare is a repository of hydrologic data, any kind of hydrologic data stored as a resource. So it's a publishing platform. Anybody can have an account, publish the resource in HydroShare, and also access other sources on HydroShare. So it's like a science base in some sense.
So that's why we do not store data. HydroShare is a good connection for us because it's maintained through the future. Actually, data on the designer of the platform is online.
Yeah.
So yeah, it was necessary to clarify this thing because we do it for storage purposes. Yeah. It stores in a very smart and organized way any type of information, not only data. It's also modeling, publications, and there are many features.
Yes. In HydroShare, just as a curiosity, as the example we just posted there, does the metadata that comes up with that file you just posted show the provenance of that data? Or is the fact that it came from eHydro now been scrubbed from?
No, actually here, right on the description, not only we acknowledge eHydro, but we are providing a link for the source of that storage.
So yeah, they are working on the Zoom call, so you can talk more about HydroShare.
Yeah, we will ask you.
So do you want me to comment on something?
Sure, I think some participants in the room, they were not aware of HydroShare, so they just want to learn more about HydroShare, and yeah, if you want to say a few things.
Sure. So briefly, HydroShare is a data and model repository that we built up over about the last 11 or 12 years. It's now operated by Quasi as a community resource, as Venkatesh said, and it's intended to support collaboration, data publication, effectively all of the FAIR principles, findable, accessible, interoperable, and reusable for data that are now importantly being pushed by organizations such as AGU and journal publishers, as well as the National Science Foundation, for making all of our data open and accessible and reusable. So HydroShare is the tool developed for the hydrology community to do this. I mean, I think it's great. I might be a bit biased since I was the PI on the development of it, but we certainly are still trying to advance it and improve it, and you can comment on any problems with it through Quasi, and they will support it. I mean, I saw on the screen briefly the resource that was created as part of that demo, and somebody asked a question about whether the metadata retained the provenance that it came from eHydro, and I think the answer that was given was that was then written in the abstract, which we can see there. That is one way to do it. That actually requires a sort of a manual intervention by the user, and perhaps that abstract was written by the API. There are other ways to do that in HydroShare as well. You can create cross-references that are intended to be a bit more machine readable, that says this resource was created by this resource sites and various other interoperability relationships. Also, whatever was in the metadata of the shapefile that was loaded will have been retained, and that was what was shown on the right of the screen when the demo was shown. So if that shapefile had in the metadata that it was how it was originally derived, perhaps it came from eHydro, then that would have been in the metadata. Many shapefiles don't come with that sort of information that goes along with them, so then obviously that's not captured automatically. But as better metadata comes across with things like shapefiles and many of you probably know that a geographic shapefile has at a minimum 3 different files, the shapefile and then some of the table files and then the metadata, but sometimes it has other sundry files that provide projection information and other metadata information. And those would all get brought along, and that's what's shown on the right in that visualization. So that's sort of dependent on what's in the data that's being imported.
Thank you, Dave, for that answer. Are there other questions from Zoom participants?
We have a question here.
Yes, yeah.
So I was just clicking around here in the interface, and I'm not finding any lines that allow me to process 2D and 3D. What's the constraint there that, I saw you were able to generate 3D and you could optionally pull down a DPM or something, a raster. So what is the constraint that allows you to do that? And how can we find those places?
Just to make sure I get the question right. So the cross-section processing tool, which maybe Changyan can chime in, provides those mesh points and lines, right? It generates those. And then the 3D part comes in only on the front end as a type of visualization. The 2D, what we call 2D visualization, is basically the points as markers. So based on that, starting from that point, could you please clarify?
Yeah, so I'm just looking at the ribbon across the top, and it says raw survey, process 2D, and process 3D. And so the process 2D and 3D seem to be inactive for most of the points that I'm exploring.
Right, so that's true. Maybe we could put a notification on that. When you click on a marker, let's say a survey from eHydro, we show the KMZ file that we retrieved from eHydro, and we enable that panel as by enabling the raw layer, right? But for the 2D and 3D to be active, you need to first use the cross-section processing tool and actually process.
Then
it becomes active and you can enable and disable.
Okay.
But that's a good point. We can maybe change the workflow on that to make it more clear.
All right, yeah, thank you for that.
Yes.
Does the processing tool do any data conversions?
So can I just make one suggestion? We will end it here, and the next session is going to continue discussion on the platform. So since the Zoom participants will sign off, so I just want to see if they have any questions. If not, we will break, and then we'll come back and spend about an hour on this. So yeah. Are there any questions online? If not, is there anything in the chat box? And okay, yeah. So, well, I want to thank all of you for participating in the Zoom meeting. I hope you learned what we are doing, and we will be happy to hear from you if you have any questions or feedback. And with that, we will end this session here. I will end the Zoom meeting, and for us in the room, we will take a 10-minute break, and then we'll come back and continue our discussion. There are some questions that we would like to hear from you. So we will answer your questions, and then we have our own questions and discussion points. So thank you. Yes,
Chat. Yeah, no.
yeah, the chat was mostly,
Yeah.
yeah. I'll follow with them.
Venkatesh, they're asking you're gonna share meeting minutes later.
Yes, yeah. I will answer.